Hello Algebra 2. We are going to talk today about section 2.6, which is all about special functions. These are just functions that you might not encounter every day, all the time. They're a little more interesting looking, so we're going to talk about these. The front is all about piecewise defined functions, or I just call them piecewise functions. The back of the page is all about absolute value functions. So this first video is going to be about the piecewise. The second video will be about the absolute value. And this is our goal today, to write and graph these types of functions. So over the front here, we are going to skip this first example. We're going to come back to that in a second. We are going to graph one of these first off. Now, how we do this. Notice piecewise functions look a little different. They have this bracket thing, and then there's three parts, or they might just have two, like the example up at the top only has two parts to it. They could have more if you really wanted them to. But the deal is, they end up looking like this. And like I said, we're going to come back to this one in a moment, but you can see that it looks different. It's not a nice curve. It's not a totally straight line. There is a part of the graph, and then it stops. And then the graph picks up and keeps going. And that's the deal with piecewise functions. They are broken apart. They're literally pieced together. That's how they get their name. So, how we graph these? Let's take a look at this first one. What we're going to do first off is I recommend pencil. Notice I'm normally working with pen on these videos, or a little marker. Pencil is good because we're going to end up erasing some of the work that we do to get the final answer the way we need to. So here we go. We are going to take the first function. Notice it's a function, and then the word if, and then an x statement. Something about x is less than or greater than or equal to, all that good stuff. So you're going to just deal with the function first, and then deal with the if statement later. And then we're going to work with the second function, and then its if statement, etc., etc. The whole way down, as many as you need. So here we go. I am banking on you being able to graph this line. X plus 1, I'll switch to marker for a second. This is x plus, 2. Wow, that is a 2. Anyway, x plus 2. We know this is in y equals, remember, this is just a y there. Y equals mx plus b format. M is my slope, m is 1 in this case. So here we go. I am going to start up at 2. Yep, this should be good. Sorry, just looking at my answer key, making sure I'm going to fit this on the graph. Starting up at 2, and my slope is 1. So I'm going to go up 1 to the right 1, up 1 to the right 1. I'm going to go as far as this little graph lets me, and I'm also going to go down 1 to the left 1. As far as the little graph lets me. So that's my line. Now, that function, x plus 2, is only good if x is less than 0. So here's the deal. Your x-axis is this one, right here. On this x-axis, that's the only one that's really important here, I need to find when x equals 0. So I'm going to label that for me. X equals 0 is right there. I only want this line if x is less than 0. X 0, that's this point right here. Well, if it's less than, that means it's this direction. It's the left side of the graph. So these points are all good to go. I like those points on this line. But I don't want any of these guys. Those are when x is greater than 0, and I don't want that. So I'm just going to erase those as best I can down to 0. Now also we have to be aware, remember when we were graphing inequalities on number lines a little bit ago? If it's just less than, I want an open dot. So if it's less than, I want an open dot for that. So I'm just going to erase this point and put the point back, but this time with an open circle. Make my line a little darker so I know that it's there. There we go. So that is the first function with its first if statement. Let's keep going with the second one. This time I want 2x plus 5, and I'm going to worry about the if statement later. So here we go, 2x plus 5. 1, 2, 3, 4, 5. That's my y-intercept. My slope is 2. Yep, I'm going to go off the graph, but that's okay. I will draw some extra lines on. Here we go. I could go up 2 to the right 1. I don't really have graph space for that right now, so I'm going to go the other direction. Down 2, left 1. Down 2, left 1. Down 2, left 1, etc. I am also going to, like I said, extend my graph up a little bit. So let me just draw some lines this way so I can see it. Can you see those on the video? Yeah, you can. Cool. I recommend drawing your own lines like that as well. So again, I'm going to go up 2 to the right 1, up 2 to the right 1. Okay, so that is my line for that one. Now I do that one very light because it does cross my other line and I want to be able to erase what I don't need very carefully. So here we go. I only want this line if x is between 0 and 2. So again, x is 0 is right there. I want that point. And it even says is greater than or equal to 0, so it can be that point. 2 is all the way over there. That point is located, for in my case, off my graph, but it's that point right there. I want all of these points. This point, all of these points on that line down to there. But I don't want anything above the x value of 2. Remember, it's all about the x value. Do not worry about the y value. I don't want anything above the x value of 2, so nothing to the right. And I don't want anything less than my x value of 0. So this part of the graph I don't need. Careful to jump over the other line that I already graphed. There we go. So notice we've started with the first function, and then it stopped. And then the other function picked up and moved on a little bit. Let's go for the third function. So now I'm on the third function. I'm going to worry about the if statement later. I have negative x plus 1. Remember, that's negative 1 x plus 1. So my y-intercept is 0, so I'm starting here. I'm going to go down 1 over 1, down 1 over 1, as far as this little graph lets me. There's my line, but I only want this one. Now I go for my if statement. If x is greater than 2. So 2 is right there. I want an open circle at 2. Greater than is this direction. It's to the right, and my graph, when I go to the right, does this. Put a little arrow. I should have put an arrow down there as well. Arrow that tells me it keeps going that direction. Now I don't want this line for any values that are less than 2. So all of these guys get erased. There we go. There we go. That's our piecewise function. Now, it is 3 pieces in this case, and notice they still create a function. We remember the definition of a function. No x values repeat. And notice how that has happened here. I have a closed dot and an open dot at 0. That's fine. The open dot isn't actually a point at 0. So this closed dot kind of fills in what's happening at 0. Same thing happens at 2. I have a closed dot and an open dot. The open dot isn't really a point, but this guy up here is, so he kind of fills in what's happening at 2. You are allowed to have gaps along the way as well. This one doesn't, and looks like none on this page do. But you are allowed to have gaps. So maybe you have something like, I'm just going to sketch this real quick. Maybe you have something that does, I'm a line, I start there and there. Then I have a big gap, and then I keep doing my thing, something like that. So you're allowed to have gaps along the way, as long as they don't overlap each other up and down. So these guys don't do that. At any given x value, there's only one point that is happening along the way. Now, real quick to end this video, let's talk about this guy. Now, it's already graphed for you. It was an example. So if you want to read that through and figure out how you graph that, it's a good example of that piecewise function being graphed. However, I would like to, and I wrote a little note here, write this one. So what I'm going to do is pretend I don't see those answers, that piecewise function right there, and I'm going to see if I can create the functions that would make this one up. So let's take a look at that. I'm going to keep this covered so I don't look at it, and I recommend you doing that too. But again, if you get stuck, you can look at it. So here we go. This first function here, I see has a y-intercept at 0. So my y-intercept is at 0. My slope, it looks like I'm going down 2 over 1, or up 2 right 1. So my slope is 2 over 1. Now, I only want that one. Well, I'll deal with that in a second. So that's that one. My second one, notice I don't have a y-intercept at the moment. I'm going to continue my slope to figure out what my y-intercept is. Or if you just want to use a straight piece of paper or a ruler or something to like figure out where it crosses your y-axis. I see that from this point, it looks like I'm going up 1 over 1. So my second function, I have a slope of 1 over 1, which is really just 1. If I kept at that slope, right there, I see that my y-intercept is -1. So I can write the piecewise function that goes along with this situation. My first function in y equals mx plus b form, so f of x is just another name for y, so y equals mx plus b. Y equals mx plus b. Those are my two lines. But I need to say the if statements now. So notice this break happens at 2. So, and there's an open dot up here, a filled in dot down here. So my first function only happens if x is less than 2. My second one only happens if x is greater than or equal to 2. Notice the difference there. The open dot gets the just less than. The filled in dot gets the or equal to part of that as well. And notice, hooray! They've cleaned theirs up a little bit. So they just have 2x. I have 2x plus 0. We know it simplifies to the same thing. X minus 1, we know that's 1x minus 1. So same thing. I would accept this answer if you gave it to me, or that answer if you gave it to me. So there we go. All about piecewise functions. So they're a little bit strange. I would recommend maybe trying these other two examples. And for this one, quick note, I do recommend counting by 2s if you want to do that one. Counting by 2s will let you fit it on that graph that they've given you. Otherwise, it might spike out a little bit. So I would recommend trying those, and we will definitely try more of these in class. The key is, and I will write this so we remember it one final time, the if statements are all about the x's. The if statements are all about the x's. Do not worry about the y-axis. Only worry about the x-axis when you are considering your if statements. Again, I recommend pencil for these. You notice I did erase a couple times. Alright, so we will continue in class with piecewise functions, and make sure you watch the next video all about absolute value functions.